Hello, welcome back. I'm sure you'd have enjoyed the little break. As from the command prompt, we already created this main.s, and if you remember, we created a startup project, startup file. So I copied this from previous, and you don't need all of this. Delete that. So I'll start from here. First line, you got to include the processor perspective directives. So hash include, you need to include the standard in that header file. Then, being this is a starter file, you need to allocate the space in SRAM. So you need to use sorry, this is a good idea, I like it. I missed the hash and it gives the help button syntax error straight away, so that's really good. So hash define, and I need to give the SRAM start address where you're going to keep that file. So that is 0x21234567 8, and unsigned, you have to leave it as unsigned. Then the next step, you're going to define the size of that memory location. So for that, hash define SRAM size. I'm going to give the size of, the STM32 has a built-in 128 kilobytes space. You're going to use that into the total bytes 1024. That's the SRAM size of 128U with 124U. Macro, all the macros will be in the size. Okay, that's macros. The next step is U is for unsigned. So the next, you have given the SRAM start address. Now you need to give the SRAM end address. To define that, just copy here, copy that. You need to give SRAM end, SRAM end, and then you need to say what the end is. End will be the start and the size. Control C, Control V, and the start and its size. SRAM size. Copy this and paste it here. Close the brackets. So we define the allocation of the SRAM to make it to reserve for this allocation. Then now we're going to say where the stack lives. So we're going to hash define SRAM stack, SRAM, and sorry, you need to say where the stack is. Stack starts in SRAM. As soon as the stack start, the SRAM ends. So that's, you have to define that. And now you need to declare your vectors in the variable format. So give this in the uint32t, uint32t, then declare the vectors in array format. Sorry, array format equals open bracket and close the bracket. So that's how you declare the array. So the first step in the array is the you need to say the reserved space for the main stack pointer. So you need to specify that first. uint underscore 32t, and then declare that as your stack start. Then the next one, as you know, it is 32. It is the reset. It will be reset handler, and then third one is the NMI handler. I'm going in by the vector table on page 198 in the reference manual, so you have to go in that order. This is how the data gets placed inside the vector table, so you need to be exactly like that. So the next one is NMI handler, yeah, and let's leave it at that for now. I'm going to create the reset handler, create the void reset. I'm writing a function so I can create the ELF handler, void enter close. Written that, so you need to specify that function declaration here after stack start. So verify this here, void reset handler, of void. So now let's go and compile it first. So to compile, you need to go to command prompt. Not here. Today we're going to use a command prompt to compile. To compile, as you know, you need to compile the startup C. So use the previous commands minus, because you are targeting the STM32 Cortex M4, minus thumb and thumb startup C and startup O. So we're going to compile first startup.c and then startup.o. So it goes and creates, because as you know, this is like in IDE you hit the build project, so now we did that. Now let's see if the directory is created. So see, we just created these two, and the directory for startup.c and startup.o is created, so we are good to go. Two directories created. Woohoo! So no error. So we have created the startup.c and startup.o. So now let's analyze what's inside this startup code. So to do that, it's a command -h. You can analyze the object file. So it's startup.o. Ta-da! Voila! There it is. It's in the file format ELF, little Indian arm, and these are all the sections what's inside the startup code. .text, .data, .bss, .command, .arm, .attributes. So this is the general sections whenever you create from a new file through this. So now let's go and modify the startup file that startup code that we just started in IDE. and this will give you a chance to learn about to create your own section. So that's my session for you to learn today. So coming back here, I'm going to modify this to include the NMI handler and the reset handler. Okay, so we did the reset, so now the NMI handler. Copy that, Control C, Control V. Instead of reset, it's NMI. NMI. Sorry guys, my typing isn't great. That's why it's a bit slow, but just bear with me. So I created that, and also pretending to write a function what's inside the function. This is just to give you an example about how you can create your own sections. So you don't have to go deep into writing big function program, what's inside everything, etc. So just the skeleton of it. So just write that. And likewise, the next step, as you know, going by the reference manual in through here. So the first one we reserved for main stack pointer. Now we have written for the reset handler, we have written for the NMI handler. The next one is on the rank is hard fault and mem manage. So likewise, you go and write for hard fault. So copy that and create the next function called hard fault. Oops, it doesn't matter, it's just a name, so it can be any name. So give that name, function creation here, just copy that and save it here. Change the name as hard fault handler, yeah, fault handler. And because we included that hard fault, so you also have to mention that in the array, otherwise it will scream and yell at you, hey, you haven't included this, include this, my friend. So that's what I'm doing here. Hard fault handler. Okay, so now we're going to save this and compile again to see what that new addition has done now. So we are not going we're going to only save here, but we are not compiling here. We're going to command prompt, and we're going to compile through here and analyze the section. So to compile, this is the startup you're going to compile, so I need to compile that, and it throws error before token expected, and there is a start stack. There are few errors which it indicates the stem size error. There is one, two. Okay, it's blaming me. I have added extra close bracket, but I didn't start with the open bracket. That's the main error. So I'll go back and fix that issue and save, go back and compile again. So it's happy, it's created. So then we need to go to the GCC file that I given you. So we're going to write more sections to create the section name that you're going to generate and create. So you have to go to the ARM options, and here you need to go to search for common variables, declare the alias names. Inside here you need to go to section 6.3. sorry, I'll go all the way up. Go to the command options. You need to scroll for common local variables, which will be on 634, 633, specifying attributes to variables. So this is what we want, specifying attributes to variables, and you need to go for common variable attributes. So this is the one. If you want to include and modify your own sections, and if you want to create and run your own variables, this is the one. You need to set your alias target by writing a short array in this format. So you need to copy this, go down and go to the section name, because you're going to copy the section name. So coming down, non-string pack. So this is the attribute you need to copy, because we are learning about creating our new section ourselves. So copy this attribute, go to your program and put that in the function window itself, in the function my handler of void, my save that attribute, and you can call that as a default handler. So every time you call this, instead of having a separate handler, you can just give it as my handler to just a default handler, so whenever you call that, this default program will run. So copy this, copy and paste it here, and paste it for the hard fault as well, session, and you leave it as default handler, and change hard fault to hard fault handler, and reset handler you change to alias name. And also you have to create the section as aliases. So why? Because you can use you can use weak statement as an alias to use the same function name when you write code. So that's why we use weak instead of section. So we use weak alias, and then you finish with the function 3. Oh, there is 2 lines. 1 2 3 1 2 3. Okay, 1 2 3 1 2 3, and you changed default handler, reset handler, default handler, attribute default handler. So you don't default handler, so you can use weak attribute so that the user can use the same name when you save the program and compile again. Okay. You save it, and then we're going to compile again in the command prompt. Compile again, see if it has any. Oh, there are a lot of errors. So what is it? The reset handler doesn't like it, the NMI handler, hard fault handler, it all comes with U in 32 reset handler, the reset attribute error. Okay, attribute error. Okay, being we used as the attribute, so you got to mention the in the vector array to eliminate all these errors. You need to mention their addresses. So you need to give their address. Save. Now go into prompt and compile. Hard fault handler of void, hard fault handler attribute. Okay. Reset handler, NMI handler, and hard fault handler. So you go reset. Oh, okay. We had to change the. We included the weak alias, but we didn't declare the new section that we created. So we need to copy that section that we want to create. Again, go to that file. We only copied the session name, so we need to copy the section attribute, which is attribute of section SR vector. Copy this again. Copy. Because we just copied only the alias target, alias var target. Now we have to copy the section target. Sorry, that's why it's throwing error. And you need to declare that in here, the attribute. Copy the attribute and call this section as the ISR underscore vector. So you just created a new section. Then open the bracket. Syntax error. Then the start stack. Okay. Now the section ISR vector. You created the new section. Now copy. Go into command prompt. Verify to make sure it's happy now. Default handler, NMI handler, hard fault handler. So what did I miss? Attribute, instead of having multiple handlers, let us have a default handler and we can copy that all the time. Okay. So we're going to call that reset handler as default handler and NMI handler. So every time when you use a reset handler, this default handler works. So you don't need a hard fault handler, and actually you don't want the alias on the reset handler. We'll leave that as reset, and we'll just use the void just for those two. Just want to show you the difference, that's all. Just bear with me. Okay, now save, and got only reset and default handler, and I'm sure now we rectified the issue. Stack start, tagging address of expression of type void, type stack start. Okay. Stack start attribute enumi and stack start. What's the error it's showing? Hard fault handler, enumi handler, stack start. So enumi handler, the address is hard fault attribute weak comma alias default handler 1 2 3 1 2 3 attribute attribute section start stack. You got to write only at hard fault. Hard fault handler, you taking that address. Okay. Enumi don't need that address. Reset. Okay. Save that and compile again. Now the enumi handler and the hard fault handler. U in32 T, the enumi handler as an incomplete type void. Expression of type void at the hard handler enumi handler. Okay. Reset hard handler enumi handler. Reset is okay. We got enumi handler has an incomplete type of void. Taking address of expression of type void. So start u in 32 underscore t enumi handler. U in 32 underscore t enumi underscore handler attribute weak alias default handler ISR vector 1 2 3 and then giving it as u int 32 t u int 32t hard fault handler. So let's check now to see if this here initialization for vector 3 at hard fault enumi. I'll go and eliminate this error, so I'll give you another brief break. When you come back, I'll fix this error and I'll explain what the startup file is doing. So please go and enjoy the break. I'll see you back shortly. Catch you later.